Dear students, welcome to lecture 5 part 3. In this lecture we will discuss about diffuse light and specular light. So what is diffuse light? Diffuse light is a soft light with neither the intensity nor the glare of direct light. It is scattered and comes from all directions. Thus it seems to wrap around objects. It's softer and does not cast harsh shadows. Here objects mean surfaces or both are interchangeably used with respect to light. So if we summarize diffuse light, light absorbed by the surface or object and then reflected equally to all directions. The appearance of surface or object reflects dullness and roughness. The diffuse light is actually implemented with the help of Lambertian law, which you can see in the rectangular box on the slide, where I is equal to KD ID cos phi, and cos phi can be interpreted as N dot L. ID is intensity of light source, KD material's diffuse reflection coefficient, N normal vector, L light source vector. N and L both were normalized for diffuse light in Lambertian law. The graphical representation of Lambertian law is shown on the right side figure, where you can see the light is reflected in two ways when it hit the object or surface to generate normal vector and light source vector. Both vector also generate reflection angle, which is represented as phi, and in the formula it could be written as cos phi. Therefore cos phi is replaced later on by N dot L in the second part of the equation. Here is the example of diffuse lighting, where scattered light hit on various objects or surfaces which wrap around the objects or surfaces to present softer appearance of the object or surface, and also appealing and pleasant throughout the image. Here we will discuss specular light, an important light type. As you see on the slide, light that is reflected from the surface unequally to all directions is known as specular light. It means the specular light highlight the bright spot of the light that appears on shiny objects when illuminated. So this light is related to shiny surfaces or objects. Specular light can be calculated with the help of Fong's law, which you can see on the left side in a rectangular box. I is equal to Ks Is cos n alpha at the second line is equal to Kd Id into E dot R raised to power n. It is not Kd Id actually, it is Ks and Is into E dot R raised to power n. This could be understood on the right side figure, where you can see that light when hits the surface or object, it reflects into unequally into various directions. Obviously the surface is a shiny surface or object, so various vectors with unequal directions were generated. If you focus on the figure, N is the normal vector, L is the light source vector, L is the light source vector. The angle between N and L is phi. R is the reflection vector, and also an I vector is generated. Angle between R and N vector is phi. So we have two phi angles at the same time, which is between N and L vector, N and R vector. So collectively we have given a name alpha. Therefore in Fong's law you see I is equal to Ks Is cos raised to power n alpha. Is is intensity of the light source, actually specular light source. Ks is material's specular reflection coefficient. In the below equation, cos raised to power n alpha can be interpreted as E dot R raised to power n, where n is an any number which can be small, large or infinity. As you can see in the below figure, from left to right, n is equal to infinity, n is equal to large, n is equal to small. Here is the specular light example. You can clearly see that light reflected unequally from the surface or object into all directions. This is all because when the light hits to a shiny objects or surfaces. Finally, you can see that how specular light is calculated and the effect of N in the Phong model. When the light hits on a shiny object, different values of N is taken to show the impact of specular light using the Phong model. Figures at the left side, n is equal to 10 and n is equal to 30 value is used, and on the right side of the figure n is equal to 90 and n is equal to 270, a very high value has been used. The resultant image with all these n values are also represented on the slide. So dear students, this is all about lighting and illumination. In the next lecture we will discuss in detail the shading. So stay tuned.